Lesson 3.1. Identify pairs of lines and angles. By the end of today's lesson, we will be able to successfully identify angle pairs formed by three intersecting lines. First, we have parallel lines. There are lines that do not intersect and are coplanar. So we're talking about this plane with two parallel lines. And for skew lines, there are lines that do not intersect and are also not coplanar. So I would have a line that can go through two planes, for example, and I could have another line in one of the planes, but this line here is not in this plane, and this line will never intersect this first line here. So that's why they're called skew lines. And then we have parallel planes, and there are planes that do not intersect, like the one I have here, drawn for you. Example 1. Think of each segment in the pentagonal prism to the right here as part of a line. Which line or the plane in the figure appear to fit the description? Part A. Lines that are parallel to line AF and containing the point E. Well, we have many lines that are parallel to point AF, such as BG, CH, DI, and EJ. Okay, but only EJ, line EJ, contains the point E. So my answer would just be EJ, line EJ. Part B, lines that are skewed to line AF and containing point E. Now, we have many lines that are skewed to line AF, such as BC, CD, okay, and GH, HI, and IJ. Now there's one that I haven't named yet, and it happens to be DE. This one. And this is the only skew line that contains the point E. So my answer would be DE. Now, for part C, lines that are perpendicular to line AF and containing the point E. Now, this is a rectangular shape here, so it must have 90-degree angles. So a line that's perpendicular to AF would only be line AE, and because AE also contains the point E. So we will write AE, line AE. Part D, planes that are parallel to plane FGH and containing point E. So a plane that is parallel to plane FGH, which is this plane, the back here, and containing point E will be plane ABC. We'll just have to pick any 3 points on this plane. It doesn't matter. Okay? Or I could just draw a plane symbol. Postulate 13, the parallel postulate. If there's a line and a point not on the line, so for example here, there's a line and a point not on this line, then there is exactly one line through the point. So this one line through this point that is parallel to the given line. So line L will be the given line. So again, parallel postulate, there is exactly one line through P, and one line through P, this line, that is parallel to line L, the second one. And we have postulate 14, the perpendicular postulate. If there's a line and a point not on the line, so if there's a line L for example, and a point that's not on the line, then there is exactly one line through the point perpendicular, so this line here is through the point P is perpendicular to the given line L. So again, there is exactly one line through P perpendicular to L. Now, example 2, use a diagram at the right to answer each question. Name a pair of parallel lines. These little arrows here represent that line AB and line CD are parallel to each other. So we can write AB is parallel to CD. And part B, it asks you to name a pair of perpendicular lines. Well, we need to look for the perpendicular symbol here. So we take line AB and we look for the other line, so it would be line AC. That's perpendicular to line AB. And part C, it asks you, is line AB, is this line AB perpendicular to line BC? We would say no, because since line AB is already perpendicular to line AC, the perpendicular postulate says there is exactly one line perpendicular to line AB through C. So if AC is already perpendicular to AB, you cannot have another line that's perpendicular to AB through the point C. Okay? And you can also give the reasons because there's no perpendicular symbol, and then we cannot assume that's perpendicular. But that would not be a very good reason to give, since now that you're introduced this postulate. Angles formed by transversals. A transversal is a line that intersects two or more coplanar lines at different points So, for instance, I could have a line here and another line here in the same plane, and the transversal will cut these two lines at two different points. Now, transversals form different angles, and they have special names to it. For the first one that I want to introduce here are called the corresponding angles. So two angles are corresponding angles if they have corresponding positions. For example, if you look at the picture here, number 1 here, angle 2 and angle 6 are above the lines and to the right of the transversal T. So because of their positions, their corresponding positions, that's why they're called corresponding angles. And the second one will be called alternate interior angles. So if you look at the positions here in the picture number 2, angle 4 and angle 5 are considered alternate interior angles if they lie between two lines. So they are between these two lines, and then they're opposite sides of the transversal T. And then the third one is called the alternate exterior angles if they lie outside the two lines, outside. So if you see picture 3 here, angle 1 and angle 8, they are outside of these two lines here, and they're also on opposite sides of the transversal T. So this angle and this angle will be also considered alternate exterior angles. Now for 4, two angles that are consecutive, meaning right next to each other, consecutive angles, if they lie between the two lines, so again, for example, angle 3 and angle 5 here, they're between these two lines, and they're on the same side of the transversal. So angle 3 and angle 5 are on the same side of the transversal. And this angle and this angle are also considered consecutive angles. Example 3, identify all pairs of A corresponding angles. So let's do that first. So angle 1 here corresponds with angle 3. Angle 2 also corresponds with angle 4. Angle 5 corresponds with angle 7. And angle 6 corresponds with angle 8. In part B, we want to look for the alternate interior angles. So remember, alternate interior angles, we have angles that lie between the lines and are on opposite sides of the transversal. So here I want to remind you guys that this is the transversal, and these are the two lines cut by the transversal. So part B, angle 2 and angle 7. Angle 6 and angle 3 are the alternate interior angles. And for the alternate exterior angles, we have angle 5 and angle 4. And angle 1 and angle 8. And then the consecutive interior angles, we have angle 2, angle 2 and angle 3, angle 6 and angle 7. And we will continue the lesson in class.